Hello, friends. Good afternoon, and welcome to Akulmach Live. And today, in the science section, we are discussing about the latest feat performed by India. And you must have noticed that the new year in India started with a successful launch of XPoSat. XPoSat is a satellite, and it has been given in the news that this XPoSat will actually study the black hole. So, what is so special in this particular satellite, and why it is so remarkable? That is what we will understand in today's stream. So, let us understand what is this satellite all about, which was launched on 1st of January 2024. So XPoSat, the name is very peculiar, and of course ISRO is actually making a lot of name and fame lately among the global community, especially the global scientific community. And XPoSat has been launched from the Sriharikota, which is the launch pad of ISRO, and this satellite has been successfully inserted into the orbit. Now, this satellite is very special because this is basically designed to study celestial objects about which very little is known. Things like black hole, things like neutron star, and why these things are so intriguing. Simply because they do not give out radiation, which we can examine and see and explore and understand. So, however, these objects are very massive, huge objects, yet having a lot of gravity, but very small, very tiny in the entire space. So they are very high concentration of material, and therefore they have a lot of emission in the X-rays, which we cannot see in the visible spectrum. That means from the naked eye, we cannot examine things. So even large satellites like Galileo and even other satellites which is like JWST, etc., they are not equipped to examine the X-rays, and therefore you need a special equipment, and therefore the XPoSat from ISRO is equipped with this very advanced equipment. And I will tell you why this is so special, because XPoSat brings India to the number 2 position, or rather say it's the second position. Right now this technology is available only with the United States. So India became the second country to launch a satellite with these kind of instruments to study neutron stars and black holes. So a lot has been said about the black holes. However, black holes actually emit X-ray radiation. Especially black holes do not emit anything, but there is a accretion disk around the black hole, which is very heated material. It's like a accretion disk of plasma. When things are getting attracted towards the black hole, because black hole in the center does not emit anything, not even light. So that is why it is known as black hole. It is the perfect black body object which is found naturally in the universe, and there are so many, countless black holes everywhere. There are certain primordial black holes we don't even have technology to examine. These are very microscopic black holes, and therefore the primordial black holes are known as the sort of in the realm of imagination or probably theories. However, when the material is falling into the black hole, it actually increases the speed, and as it is falling inwards, it starts rubbing with the other material, and that generates heat. And also as the material comes closer and closer to the black hole, the speed of falling increases. So much so, it has been said that the accretion disk is rotating almost 1/3 the speed of light, which is very, very fast, extremely fast. The material itself is rotating at such high speed, therefore there is a lot of heat. In fact, these areas are one of the hottest areas that can exist outside the stars. These are trillions of degrees of temperature, and they give out a lot of X-rays. Not so much in visible light, of course visible light is also there, but a lot of X-rays are also emitted, a lot of high energy radiation. For to study the X-rays, we need X-ray the various instruments to basically look into X-rays and then examine these things. And if we have the X-ray instruments, then probably we will be able to have better prediction about the neutron stars and black hole. Same is the story about the neutron star, because neutron star does not have any heat engine running, but they are very, very hot, and they actually start exerting a lot of gravity in the neighborhood, and they start pulling things. Whenever something falls into neutron star, it emits a huge explosion of X-rays and also gamma rays. So we need instruments which can examine this, and therefore India has actually, or ISRO has been able to launch and thus became the second agency to possess this kind of technology, and therefore our understanding of black hole will also improve, and then we will be able to share a lot of new findings with the global scientific community. So XPoSat is designed to operate from outer space, where there is no radiation, there is no interference, there is no light pollution, there is nothing like that. And it has very specific instruments on board. I will tell you what are these two very specific, very important instruments today. However, the whole idea of XPoSat is to basically make study in the X-ray spectrum. And when we talk about X-rays, what are X-rays? X-rays are photons of light, very, very extremely energetic. They are so energetic that they can pass through objects, things like our bodies. We know that we go for the X-ray in the medical term, and then we take the picture on the other side on a photographic plate. So X-rays are very energetic photons which does not interact with the matter. It just passes through the matter. And then there is another type of energetic photon which is known as gamma ray, and they are even more energetic than X-ray. So these are very, very high energy light, a form of light, and to study very, very high energy you need a special camera, which is an X-ray camera. And then once you are able to have that instrument, then you can pretty much do everything what you can do with the light, because we use lenses, we use all kinds of stuff, digital light, etc. But you need a X-ray camera, X-ray receiver, and once you are able to do that, you can play around with that. And this is where the instruments which are on board on XPoSat comes in the picture. The first instrument which is on board on XPoSat is POLIX. POLIX is an abbreviation. It stands for polarimeter instruments in X-rays. So it measures the polarization parameters of X-rays, revealing the hidden and their origin and their journey. So whatever goes through with the X-rays, this instrument will be able to gauge that and also identify that how far the X-rays are coming from, what was the condition of the X-ray, what was the energy at the origin, from where it started, and how much time it has taken to reach us. And remember, the X-rays are the photons. They are a form of a light. Therefore, they follow the principles of the universe. That means they travel at the speed of light. So how far the origin was, that means the black hole in the subject, or neutron star, and what has happened to the X-ray during the transit. That means that if the light has taken millions of years to reach us, then did it get stretched, by how much, and so on and so forth. So basically this instrument POLIX is able to study all these parameters about the origin, destination, and journey of the X-rays. Very, very important, very critical instrument, which is completely manufactured, produced by the Indian scientists. The next instrument which is on board of XPoSat is the XPECT. It is XPECT, which is the in short XPECT. It is basically stands for X-ray spectrometer, spectrometer basically. So as I said, that if you are able to have instrument, then X-ray will also behave like light, and if you have a proper instrument, then you can pretty much do all kinds of experiment with X-ray like we do it with light. So in order to identify the origins, chemical composition, atomic composition, we actually do spectroscopy. We do this with visible light all the time to identify what is present on these distant stars and also exoplanets or anything else. So if there is visible light, we actually divide that light into a spectrum of things, and then based on what kind of light the spectrum is giving us, we know that okay, fine, this object has chlorine in it, or this has oxygen in it, it has hydrogen in it, because each of these, once the light is split into constituents, then the color of the light will determine whether there is hydrogen, there is different elements on in that object. Also, how much redshift it has taken, because as you know that the farther the distance, it actually loses energy. The light beam actually loses energy and becomes redshifted. So the spectroscopy, the science of spectroscopy will tell us how much it has lost its energy. That means how much it has redshifted, and therefore we will be able to determine how far this object is. So once we have this aspect meter on board, and when it starts operating, we will be able to tell a lot of parameters about black holes and neutron star based on the spectroscopy which is being performed with the X-ray which is getting it. I mean, the XPoSat will not study any visible light. It will study everything in the area of X-ray. Very, very specialized machine. Therefore, this is something remarkable. And it has a very long life. XPoSat is having a life of 5 years. So for 5 good years, XPoSat will actually start focusing on various known black holes that we have already identified in close vicinity or even far off vicinity. We know exactly where these black holes, where are these neutron stars, and then XPoSat will start focusing using its instrument into those direction, and will get a lot of vital data which has been missed so far. Because if you study more, obviously it is good for the scientific community. So therefore, it is very exciting. It is having a shelf life of 5 years. It is going to study all these very dense, very energetic objects for nearly 5 years. So it's remarkable. I think it's a lot of foresight that the ISRO had. I mean, they are sending various space probes to Mars and Moon, but they are also not getting defocused from the bigger things in life. You know, the whole question is how our universe function, and some of the things which are still hidden from our scientific knowledge is the black hole. You know, what happens once something goes beyond the event horizon? That is where the laws of physics fail. So I think that is where the whole crux of the matter lies, where the bigger things, how universe function, how universe was formed, some of these answers will come from such studies. Therefore, ISRO is very focused. They are also looking at transactional items which are sending man to the space, man to the moon, sending probe to the Mars, but also not ignoring the bigger picture. So that is where it is so remarkable. And because of this trend or the ISRO strategy, the launch of XPoSat has been celebrated on 1st of January. It was celebrated world over, specifically in the scientific community worldwide, because so far US or the NASA has been leading this effort of studying the black holes and large objects and universe origin, etc. Now there is another space agency which is going to do independent research and contribute to the knowledge and study of these objects. Probably the scientists on this side and collaborate with NASA, and they may come up with the difficult answers that the mankind is still waiting for. You know, the answers are still not coming through. The new findings are not happening, and therefore the XPoSat launch is an amazing feat. And specifically, the symbolism of XPoSat is also amazing because it was launched on the 1st of January. This shows, you know, how the ISRO wants to start the next year, the new year, which is 2024. On the very first day, they announced to the world, here they are launching something latest, and they are the only second country in the world to have this kind of technology. All right, friends, if you have any question on this, feel free to send it across. Otherwise, I will see you again in the next edition of Science Show.